where in that happy parabola right now is it greater than 0? The pink sides. Where is it less than 0? The blue. What if it was a sad parabola? Where is it greater than 0? The red. And where is it less than 0? The green. Since there is only one variable, does any of the yellow values matter? No, because the y values do not matter. Because obviously, as we proceed this way down the x-axis, all of the y values are lower than 0. Does everybody understand? I think I did a poor job of that on the first day. I thought I didn't, but as we have progressed through, I seem to be getting that vibe. So I'm hoping that this makes it easier. Yeah? Now, obviously, the next thing we're going to do is have to worry about those y values. But we're not going to get there till tomorrow. So don't worry about it. We're all cool? So if we can graph it, we know the answer just by looking, yes? All I got to do is look at that. As long as I know those two values, and I can read those symbols, which one is this? Less than. Which one is this? Greater than. If I can read those, then I can solve this with just a graph, just by looking. Yeah? That's number one. Number two, as Qui says, you can use a number line. Since the only thing I care about is the x-axis, that means all of this is not important, is it? The only thing I care about is the x-axis. So that's going to give me three options. I could have root 1 and root 2, yes? And that would mean the x-intercept is split into 3. And I would have to check 3 test points. That's if I have a parabola that has 2 roots. What is another option for a parabola? No, this isn't case analysis. This is a parabola. A parabola can hit the x-axis twice. We know that. What are the other options? It can hit it once. You could have 1 root. And what's the third option? No roots. It could be like that or like that, yes? So in this case, how many test points do I need to check for positives and negatives? 2? For this guy? If this guy is positive, you got to check 3, right? But if you know what the parabola looks like, you can get away with 2, can't you? This one, check both sides. This one, you don't need to check at all if there's no roots, because it's not soluble, is it? And then the third case is case analysis, which I'm going to go over pretty heavily on this page. I'm going to assume that all of you are going to choose 1 and 2 to do this question first. That would be my guess. So why don't you go ahead and do that, and then down at the bottom of the page, I will do another in-depth case analysis, because it takes a bit of practice, okay? So everybody do the first 2. Once you do one of them, you obviously know the answers, right? So the other one shouldn't be too hard to figure out, okay? Everybody cool? All right. So, or do we want to work through it together? I don't really care. What do you people need? He waited patiently. Try it first. Go 2. For you all to factor it before I turn the screen back on. Has everyone got it factored? And what are your factors? x minus 5 and x plus 2. But of course, you have that negative out in front because you factored it out of the original equation. So you have a root at 5 and a root at negative 2. Yes? Happy or sad parabola? Sad. Does the vertex matter? No. All that matters is we draw that because that's all we care about. We do not care where the vertex is because y values mean nothing to us when there is only one variable. Good question. You should draw it dotted, but since we only care about the x values, we don't need it to be dotted. But we could. Tomorrow you're going to need to remember when to do dotted and when not. For here, all that matters is 5 part of the answer? Which is it, Jacob? No. Why? Because it's not equal to 5. So you just got to remember that's open dots, right? So where is it less than 0? Yellow or green? Green. When is the parabola green? When x is what? Greater than negative 2? Okay. So when x, so Jacob wrote when negative 2 is greater than x. We don't like to write it that way, do we? We like to put our variables first. So that would be x is less than negative 2. And when else? When 5 is less than x, which would be x is greater than 5. Easy to see from looking at it, yes? Okay. That was method 1. Method 2, now that we've already done it, is super easy. Number 2, our x axis has been split into 3 spots, and I just check 3 points. I could check any point there, any point there, and any point there. If I check 0, will that, if I know what I am doing, is that enough to check just 1 point? Well, let's check. If I put 0 in, do I have to put 0 into the original equation? That's a bit of a pain. I could put it in there too, couldn't I? But putting it up there is pretty simple, right? What's going to happen to both those x's? They're going to disappear. So I'm going to be left with 10 is less than 0. Is that true? No. So 0 is not allowed. That means this whole region is not allowed. Since you know what the parabola looks like, you know it's a sad parabola, you know it crosses the x-axis at those 2 points. If this is not okay, then these 2 must be okay. And I can just write x is greater than 5 and x is less than negative 2. Right? Everybody cool? If 0 had worked, if it was this, if it was negative x squared plus 3x plus 10 is greater than 0, I should have changed colors there. If it was negative x squared plus 3x plus 10 is greater than 0, then what would the answer be? It would be the opposite. This would all be garbage, and this would be correct. So how would I write that section of the x-axis? Okay, now this is where your skill needs to come in. It's less than 5, but it's also greater than negative 2. Yeah, but you would not read it that way. You would read it as negative 2 is less than x and x is less than 5. Just like we did last year when we were doing domain and range. Everybody cool? All right, now let's take a moment and actually explore case analysis. Because even though I don't like it, I do need to show it to you. So we know that this was our factors, yes? Right? And we know that they had to be less than, not 10, less than 0, yes? Which means this side of the equation, inequality I mean, would have to be negative, correct? The only way to make that negative is if one of those factors is negative, right? So our options are this side, negative x minus 5, would have to be less than 0, right? If that side's negative, then what would this side have to be? Would have to be greater than 0. Because if that was negative and that was positive, we'd have a negative answer, right? Does everybody follow me? And what's the other way that it might work? Negative x minus 5 could be the greater than 0, 1, in which case x plus 2 would have to be the less than 0, 1. Is everybody cool with how that works? Like just this line. Not what we're going to do with it yet. Everybody understands why these are our two cases that could be true. Yeah? Because right now, in black, this one is negative. So if this one's positive, I'm going to be okay, right? If this one's positive, then this one's going to be negative and I'm going to be okay. Everybody cool? So let's do this one first. First of all, I want to work in black. So negative x minus 5 is less than 0. How do I get rid of that negative? That's gross, Quee. Holy crap. How do I get rid of that negative? I could distribute it in, which would get me negative x plus 5 is less than 0. Happy? Okay. Negative x is less than negative 5. And then x is what? Greater than positive 5. Because when I divide by a negative 1, I got to flip the sign, yeah? Okay. And then this side's easy. It's one step. X is greater than negative 2, right? Everyone's cool with that? Okay. So here's my number lines. That should have been a different color. There's my number lines, yeah? So, if I'm working with the black side of this equation, I've got, I shouldn't have colored that in, sorry. I've got 5, and I would go that way, yes? Everyone agree? And I've got negative 2, and I'd go that way, yes? And you can quite plainly see that it isn't until I get to here that both of them are okay. Right? Everybody's good? Okay. So I'm good as long as x is greater than 5 for both of them. Agreed? So I know that part of my answer is x. Didn't want that to be red. Part of my answer is x. I didn't want that to be red. Part of my answer is x has to be greater than 5, yeah? Now, if I work with the red side, I'm going to do the same thing. Negative x plus 5 is greater than 0. Negative x is greater than negative 5. X is less than 5. Agreed? I think my pen has started to crap out. It has. We're going to wait a minute because apparently I've discovered that if I wait a while, I don't need to restart it. I just need to wait till it decides it's going to work again. So let's talk amongst ourselves for a moment. Yeah, it is. It's stupid, right? Like this case analysis, I don't know why anybody ever uses it. It's so much more work.
I mean, I had to do it with it actually worked class. I'm explaining my argument. I had to do a quiz in this class because I came in late from a dentist appointment.
Dude, have I ever asked?
Nah, I'm just trying to let you know I'm a making small talk.
Oh, we're making small talk, right? Fair enough.
I already told the kid from the other class stuff. I poisoned them.
Oh, great. Well, anyway, it's not working. X would have to be less than 5, yeah? So in red, it would be down here. La, la, la. Right? And then obviously this one, X is less than -2, which would have to be down here, yes? And the only place that works is down here. Right? So the only place they both work is greater than 5 and less than -2. Everybody cool? Yeah? Okay. Turn the page over and we'll see if my pen starts working by then. Sometimes when we're playing rugby as old boys, there's not enough old boys, and we have to go to non-contested scrums. Somebody always does the gag when you're on the defense. Big push, guys, steal this one. Always. That's kind of like the way if my pen's out of ink. I do too. They're stupid. Oh my gosh. All right. Well, we are going to talk about this one. What is different in this one compared to what we've been doing all along? Qui. It doesn't equal, it's not an inequality with 0, right? But is it easy to fix? Yeah, I know. Is it easy to fix? How would you fix it? You'd move 12 to the other side, and then what would it look like? It would look exactly like what we've already been doing, right? Okay, so if we move that 12, I'd have 2x. Hey, we're back! Would be greater than what? 0. And now, is there still only one variable? Yeah, so we only care about x's, right? So we only care about roots, right? What's the easiest way to find roots if it's going to work? Does that factor? You can think of factors of -24 that add to 7? Yeah, we got to put in the 2. Are there factors of -24 that add to 7? 1 and 24? 2 and 12? 3 and 8? 4 and 6? Does it factor? So what's our other option to find roots? No. Complete the square finds the vertex. What finds roots? Quadratic formula. So what's A? 2. What's B? -7. What's C? Go. How many people remember the quadratic formula? Maybe you don't. So fill her in. 7 plus or minus the root of 49 plus 8 times 48. That is minus 8. That's 145 over, why is this one taking long? 2 times 2, 4. Yeah? Do we need anything else? Those are the roots. One of the roots is what? 7 plus root 145. I just gave away 145 over 4. And what's the other root? Root 145 over 4. Do I need exactitude here? I don't. What could I use that would allow me to continue to work right away without thinking about it? No. What's this really close to? Which has a square root of what? So one of the roots is very close to 7 plus 12 divided by 4, right? What's 7 plus 12? Divided by 4. What's really close to 19? So 20 divided by 4 is what? 5. So 5 is real close to one of our roots, yes? What's the other one? What's 7 minus 12? What's -5 divided by 4? It's pretty darn close to what? 4 over 4, which would be -1, right? So now, do I know my roots? What are they? Approximately 5 and -1, right? Is it a happy or a sad parabola?
It's happy.
Whoop. So where is it greater than 0? When the line's above. So up there, yes? So x must be greater than what? We can't say 5, but we know that 5 is this one, yeah? So 7 plus root 145 over 4. Or x is less than 7 minus root 145 over 4. Now, do those values help me in real life? Not really. So now what could you do, Ashton, if we were in real life? What would we use? We'd use our calculator, and we'd do 7 plus that divided by 4. And we get slightly more than 19. So somewhere around 4.9, 4.8. Would this have worked with your method?
I think so. I just need the roots.
So you got to do all the work anyway.
But then I don't have to do that. I just write it.
Okay. We all good? Yeah? Okay. So you guys do that one, and then we're going to do the key points, and then I'm just going to get you to do some work with this, because I gave you no work over the long weekend. Why? Because my Grinchy heart was 2 sizes. Actually, it was a 4-day weekend. My Grinchy heart was 4 sizes too big. And over the weekend, I went to that indoor Christmas light festival thing in Vancouver because a friend of mine was playing in a band there. So my Grinchy heart grew even more. Although my Grinchy heart got a little bit bothered by how much everything in there cost. It was pretty crazy. Oh, hey, I'm going to be really mean. No, I'm not. Yes, You can solve this one with any method you choose. I am going to use roots and a test point just to be, all right? Okay. Is that all I need to do if I understand parabolas? This is a happy or sad parabola. So it's going to go like this, yeah? Right? Where are the graders?
X is greater than 2 plus or minus
Out here
plus 3 or 4.
and down there. So I really would only need to check 0, right? Is 0 greater than 10? No. So this region in the middle is no good. So it has to be the other two. And how do I write it out? I would write x is less than 2 minus root 14. Right? x is greater than 2 plus root 14, and then a comma, x is all those real numbers that work there. So like 2.1 or 6.1, 7.035. Okay, you've got it, because when I asked you to explain it, you were like, well, if it's this, and it's this, and it's that, and it's this, and it's that, and it's this, and it's this, and it's that. Have you distilled it down?
I wrote it down.
Okay, so everybody listen. Jacob's taking the pen. Okay, we're going to go to the bottom of the next page, and we are going to add Jacob's method. If you wish to write this down, you are welcome to. Jacob, I relinquish the throne to you.
Oh, I have to write it down.
Yeah, you do, brother.
Oh, it's going to be so messy.
You can handle it. Go, Jacob. It's your birthday.
All right, guys. I'm the teacher now. Uh-oh.
Wait a second. I have to be a student. Wait.
All right, so first, you find the... Oh, it's so messy. Find the roots, right?
What's a root?
I don't know.
Alright.
All right. Then, so you get two different roots, and there's going to be
Why is there two?
I don't know either. So there's going to be one that's like lower and one that's higher, and the lower one comes first. Oh, this is so
The
confusing.
lower one comes first?
Yes.
What do you mean?
I don't know.
I'm not gonna lie, you look kind of hype. Like, this Myers, you should start wearing a chain.
How it is?
Yeah.
Maybe I should get two, then I'd be two chained.
All right, so then...
I'd be that guy.
So then...
I'm from the east side of Abbotsford, so I'd be east.
All right, so let's pretend it's like this, right? If you have that and it's a negative, and this is all like less than something. So if it's a positive parabola, you use the one it gives you, and if it's a negative, you use the opposite one. So then you just do 1. Okay, so this, because it's negative, you're gonna use the opposite x, opposite 5, and you're done. And it's always worked.
But that one is...
No, that's not the right numbers for this one, but that just,
Oh, I see what you're saying.
it always works.
Does it always work?
Yes.
It's 100% of the time.
I thought it didn't work.
99.9% of it didn't work once. That's because I didn't refine it yet.
Oh, okay.
Okay, why don't...
Thanks for coming to my TED Talk.
Well, I hope that cleared it up for everybody. Thank you, Jacob. Jacob will be appearing here periodically till the end of January.
I know it looks so bad.
Yeah. When we try, that's
All right. But seriously, folks, that takes guts. Well done. You have noticed that this unit, because we haven't talked about it, inequalities, since the 9th grade, I've gone out of my way with each lesson to summarize it all at the lesson instead of doing this at the end of the whole unit. So the first thing you got to remember, key ideas, remember these are quadratic inequalities. Not just a straight line, right? Quadratic inequalities. The answers still, the solutions are still a set. Right? It's not just x equals 7. It's a set of numbers, right? If there's one variable, quadratic inequalities in one variable, I suppose we should add, because tomorrow it's going to be slightly different. The solutions are still a set. And that set is always a portion of the x-axis. And that is 3 options, right? A, it could be this, root 1, root 2. And then I've got to check where it fits. Then it's either going to be this or this. And it just depends on what you're being asked for, right? So your answer is if there are 2 roots, your answer needs to have 2 numbers in it. So it's either going to be root, if it was in green, that's a greater than 0, right? If it's in green, then it's going to be root 1 less than x less than root 2. Right? Or equal then. I don't need to do or equal then, do I? Everybody's cool with the colored dot or not colored dot? Okay. That's if I'm on the green one. If it's greater than 0. What would it be if the green one is less than 0? Then what would I write? What would my solutions look like? Kind of, you would flip the sign, but you put the x's first. So x would be, if it's less than 0, x would be less than root 1, and x would be greater than root 2. Everybody cool? And if it was the red one, it would be reversed. Right? The next option, B, is when it just does this. Boop. And there's root 1. Yeah? If that parabola, if it's greater than 0, then what are the x's? Isn't this always greater than 0? It would be x. There's no equal sign here. So is root 1 part of the answer? No. So it would be x cannot equal root 1, but x is all the rest of the red numbers, real numbers. What if it was greater than or equal to 0? Then what would it be? X is just all the real numbers, right? What if it was x was less than 0? What would we write here? Is there any solution? No, no solution. What if I wrote x is less than or equal to 0? What would it be? One solution, and what would be? X equals what? Root 1. Everybody cool? And then, of course, the third choice is when it's one of these, like that or like that. X is greater than 0, all the real numbers. X greater than or equal to 0, still all the real numbers. X is less than 0, no solution. Down here, x is greater than 0, no solution. X is any less than zeros, every real number. Everybody good? And that's the sets. All right? There are 3 and a bit strategies to find these roots. There's the 3 I've shown you, and there's Jacob's. If you followed this, go ahead. It works for Jacob. 1 is graph it. And then we know by inspection. We simply look. If it's greater than 0, then I am seeking the parts of the parabola that are where? Right. Above 0? Parts of the parabola above. What, Jacob? The x-axis. If it is less than 0, I'm seeking the parts of the parabola where? The parts below. The x-axis. And it doesn't matter if it's happy or sad, right? You just got to know if it's greater than, you're looking above the x-axis, less than, you're looking below. And the last thing you got to remember, the last thing to remember about these is, oh, wait, I forgot the other 2 methods. Roots and test points. Root 1, root 2. If you can use 0, it's good, right? But there is region 1, region 2, region 3. If you check a point in region 2, is that all you need?
Yeah.
Yeah.
Because if it doesn't
Yeah, because if I have x is greater than 0, and my test point 2 does not work, I'll highlight that in green. Test point 2 doesn't work. Where do the answers live? In which regions? 1 and 3. Yes. And if it's x, if test point 2 works, not TR2, test point 2 works, it is greater than 0. Son of a... It's in there. Right? And I don't need to flip it around, do I, for a sad parabola? We all get it, right? And then lastly, the one that nobody ever wants to use, case analysis. Factor 1, factor 2, greater than, or factor 1, factor 2, less than 0. Then you just got to know, if it's greater than 0, they both have to be what? Both positive or both negative. So factor 1 would have to be greater than 0, factor 2 would have to be greater than 0, or factor 1 would have to be less than 0, factor 2 would have to be less than 0. What about over here? Factor 1 would have to, if factor 1 is less, then factor 2 would have to be what? Greater. If factor 1 was greater, then factor 2 would have to be less. And then you just put them on a number line and see where they all work. Everybody cool? I'll tell you right now, barring teaching you case analysis, I have never come across a time I have needed to use it when doing math. I have always been able to get by with either graphing it or the roots and the test points. Always. But it must have some use. Somebody must use it. And finally, the last thing is just remember the greater than, less than, or greater than, equal to. So the third thing, just remember that and that. Do they include the roots? Roots not included. And then, of course, I'll change to a different shade of green. That and that. Roots are included. And then Jacob's method. Right? It's a work in progress. Hey, man, all these methods were works in progress at one point. Right? Everybody cool? All right, your job today, start it now. You should be able to finish today, is 145 and 146. Now, in my other class, some of the kids thought that this was a multiple choice question. It's not. I want the answer when it's less than 0, less than or equal to, greater than or equal to, less than, greater than or less than. You need 4 answers here. One of those is not right, okay? These are not multiple choice. You will need 4 answers for all of them. For the first 2. Everybody cool? You will also notice that I have provided you with the answers on each page, so you don't have to be flippy. Because I know all of you have that weird confidence thing where you know even if you did it right until you check the answer, you refuse to believe you're right. As always, I could give you 7 plus 2 equals X. And you know it's 9, but I would still see all of you turning your book over to check if 7 plus 2 is indeed 9. And then, if it was a misprint and it said the answer was 10, you would come to me and say, Mr. Myers, how can 7 plus 2 be 10? And I would say, kid, it's just a typo. Okay? Okay. Of course, I wouldn't call you kid. I would call you by your name. It's not like I don't remember who you all are. Go.